Alright, let's check out what we got on this test. So, the first thing we had to do is we had to change this exponential equation into a couple different representations. So when we were going from equation to table, we were plugging these x values in for x over here. So if we plug in, I'm going to start with 0, because if I plug that in, I have 5 times 1.8 to the 0th power. And remember, anything to the 0 power is 1. If we want, we can type it in the calculator too, but we're going to end up, this is part is 1, so 5 times 1 is 5. Now the other parts I'm going to have to type into the calculator, but I can see 1.8 is my multiplier, so if I didn't want to put the whole equation in, I could just type 5 times 1.8 into the calculator, or I could do it by hand if I really wanted to. I'll end up at 9. Then I can multiply that by 1.8, and we get 16.2. Now to get to this negative 1, we could do the same thing. We could put the negative 1 in as an exponent. Remember, you got to put it in as an exponent. Or we can go backwards. Since we multiplied, we have to divide. So if I do 5 divided by 1.8, I end up at a nice fraction. 2.777777778. So we can either say that's 2.7 repeating, or if we want to round, we'd have to say it's 2.8. So you can't say it's 2.7 because you have to round to 2.8. So our next step is we got to turn it into a graph. So on my x-axis, I don't have too many points. I just have negative 1, 0, 1, and 2. My y-axis, I got a lot though. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that went up a little bit over it. That's okay. 2, 16 and a half. I'm going to go all the way up here. 16.2 will be right there. 1, 9. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. That's about right there. 0 goes with 5. And then negative 1 goes with about 2.8. So we get the curve right there. And you can see it's starting to kind of bend a bit. So we can connect our points and we can make it bend. So remember, we have an exponential graph. That didn't go so well. So remember, you have to not cross the x-axis. We have that asymptote there. So as long as you didn't cross, then we're pretty good. Some people just put the data points. That's okay. Those are what our data points say. Some people connected them with a line that didn't have the arrows. That's okay too. Just remember that the arrows are there, and we do have that asymptote over there. For the situation, usually we've done these decimal multipliers as just interest. So you could say that it's an 80% interest on a $5 savings account. Now some people turned it into like $5,000. Some people came up with some pretty crazy situations, which are pretty fun. Somebody came up with like a sewing machine that cost $5, and then you're making so much money making clothes. That was pretty interesting. There was one with an airplane kind of taking pictures, and then we had 1.8 of the city was being shown or not shown as it kind of descended and ascended. So that was pretty cool. So nice job. People were very creative with that, which was really good. For the second one, we've got a table, and we need to turn that into an equation. So we looked at making these just so many steps. So we looked at calling that 3x, and that's 3x times x. And then that's 3x times x times x. So we know that these two things are the same. So we say 648 equals 3x cubed. To solve for x, we divide both sides by 3. So we can do that. We'll get 216. Oops, divide by 3 to get 216. And then we'd have to either take the cubed root of 216, or we'd have to kind of guess and check, well, what times itself 3 times equals 216? The numbers are nice on this test, so you were able to do either method. It turns out that x is going to be 6. So for our equation, we have y equals a b to the x. And what we have to do is fill in. So we know this x is actually, remember, that's b. So I'm going to put a 6 there. Kind of looks like my b anyway. And a is where we start at. We always start at t equals 0, so we're going to start at 3. And we have our equation. Down here, we had to go from a graph to an equation. I'm going to take a different strategy. I'm going to say this is going, I'm dividing by 2 that way. So to get to 1, I'd have to divide by 2 again. So that would be 3. And to get to 0, I'd have to divide by 2 again. So that would give me 1.5. So I would divide by 2 every time. So my equation, again, same form. Y equals a b to the x. My multiplier, if I go this way, I'm multiplying by 2. So watch out, that's a little bit tricky. And then my a value is where I start, and I'm starting at 1.5. Alright, on the back we're going to kind of look at the idea of paying it forward. So we're going to look at our data and see if it fits a linear equation or an exponential equation. So the nice thing is we're given just the general form of the linear equation in case we forgot, and also the exponential, which we could have used on the front too in case somebody forgot that one on the front too. So there's a little bit of a hint in the test. Kind of tells you a little bit what to do on the front also. But we have our 2 data points. So it says after 1 week, so that's going to be a 1, there were 3 people. So I know my point is 1, 3. And then I have my second data point. It says after 4 weeks, we have 81 people. So those are my 2 points. On the linear side, we've got to do a linear equation. So to get that, we want a slope and we want a y-intercept. So we're going to find the slope. And remember, that's the delta y over delta x, or the y2 minus y1 over x2 minus x1. So that's going to be 81 minus 3 over 4 minus 1. X1, Y1, X2, Y2. So that's going to give us 78 over 3. And so then we can divide 78 by 3 and get 26. So we have m. So now we plug in and solve for b. Y equals mx plus b. We know a y value is 3. M we know is 26, X is 1, and B is B. We got to plug in and solve for B. So we're solving for B. So 3 equals 26 plus B. Subtract 26 from both sides. Negative 23 equals B. And so to finish it off, we'll do Y equals 26, X minus 23. So that's the linear equation. Not too crazy. Plug in and solve for b. On the exponential side, this is where things can get a little bit crazy. But remember, we've done a couple of these in class, and we also looked at different ways to do these. So if you didn't like this method, a lot of people chose to do it with the table, similar to how the ones with the table was done on the front. And that's totally okay. But just to mimic this one, we're going to find the multiplier, just like we found the slope before. We'll find the multiplier and plug in and solve for our last value. So I'm going to set up the general equation, y equals ab to the x, and I'm going to do it for each of my 2 equations. So 3 equals ab to the 1, so 3 and 1. 81 equals ab to the 4, 81 and 4. So then I need to find out, what do I need to multiply 3 by to get to 81? Well, just like in class we did, okay, 81 divided by 3 is 27. So I know that 81 equals 27 AB to the first. So I multiply both of these pieces by 21. By 27. 3 times 27 is 81. This side times 27 is 27 AB to the first. So we've got that up. Now we know that these 2 numbers are the same, so we can set these 2 things equal to each other. 27 AB to the first equals AB to the fourth. The a's are the same on both sides, so you can divide by a, they'll become 1. And then we want to divide away from the number. So we're going to divide by b to the first. So b to the fourth divided by b to the first, that's b over b, those cancel to 1. So I get b cubed. I have 3 b's left over. So I'll solve for the cubed root, or again, guess and check to find out what times itself 3 times gives me 27, and I get 3. So since I know b, just like we plugged in and solved for b over here, now we're going to plug in and solve for a. So I'm going to take this one up here and say 3 equals a, b is 3, to the first. Okay, well 3 to the first, that's itself. Anything to the first is itself. So 3 equals 3a, divide both sides by 3. 1 equals a. So I have all of my parts. Y equals 1, 3 to the x. And that's the equation. Again, you could have done this with the table if you like the table better. That's totally okay. You'll get the same answer either way. And so the interesting thing is we can come back up here and kind of look at the whole situation we have. And it's like, well, where do we start at? Do we start at negative 23 people being kind or one person being kind? Well, for our pay it forward idea, it's kind of one person giving it to 3 strangers, so it's probably exponential, not linear. Which is good, because then it'll grow a lot faster. The last question, Rihanna was wildin', so it's about 4 or 5 seconds from wildin'. So I'm going to make a chart. I think this one would be best with the table. So we know that she's 4 or 5 seconds. And at 5 seconds, her anger level was at a 100. And at 4 seconds, her anger level was at a 20. So we'll put a 20 there. So we need to step back because we have to get a and b, just like we had our other equation up here, y equals ab to the x. We know that because it says she was getting exponentially madder. That's our exponential. So I got to find out what a is and what b is. Well, b I can figure out 20 times what is 100, or if I wanted to divide 100 divided by 20 is 5. So my multiplier is 5, so b equals 5. So I'm going to step back. 20 divided by 5 is 4. I'm going to step back. 4 divided by 5 is 0.8. I'm going to step back. 0.8 divided by 5 is 0.16. I'm going to step back. 0.16 divided by 5 is 0.032. And I know that this is my a value. So I've got y equals 0.032. 5 to the x would be my equation. But if we look, the question's actually asking what was her anger level at the start. So if you put this, that's great, that's correct, but it doesn't answer the question. The question wants to know what's her anger level at the start, which is the a value, that one right there. So the answer is just 0.032. We didn't even need to make the equation. Part of this one was just knowing that this is the start, not this one. So if you didn't actually pick an answer, if you didn't put something down, then you did lose a little bit of credit for that one. Because part of the reason that this one's on here is to know that, okay, 0 is where we start, not 1.